Good morning, everybody. We're going to go ahead and get started. My name is Lori Craner. I'm the director of CyLab, and I am very excited to introduce today's session. So a little background. In CyLab, we did some strategic planning a couple years ago, and we started trying to think of a new initiative that would that a lot of our CyLab researchers and partners would be interested in getting behind and would be something fairly unique and helpful to the world. And one of the ideas we came up with was to focus on the security and privacy side of robotics. And CMU seemed like an ideal place to be doing this work because we have CyLab and all of our security and privacy work, but we also have a robotics institute here. And so we thought that getting these great teams together would be a great way to actually advance the field. I'm not a roboticist. I'm not an expert in this, but fortunately, I have colleagues who know a lot more about this than I do, and they were willing to step up to organize our new robotic security and privacy initiative. So you're going to hear from some of them today. The co-directors of our initiative are Basti, Unsuk, Liman, and Sarah, as well as Chris Timperley, who's not here today, but is also part of this. And they worked together to organize a workshop this summer along with Ding Zhao and Rebecca Martin. And they put together a program for us. So today you're going to hear from some of our co-directors, as well as Jorge Merchant, who is a longtime friend of CyLab, who works for Bosch here in Pittsburgh. So with that, let me introduce Unsuk, who is going to get us started.
Thank you for the introduction. So let's see. Okay. All right. So let me tell you a little bit about the workshop. So I guess one question is, why do we care about security and privacy of robotics? As you probably know, there's more and more robotic systems that are being deployed in our lives, in our homes, in factories, restaurants, hospitals, and many others. And in proportion to that, there's also been an increasing amount of attacks that are being discovered on these systems. And some of these attacks are actually quite scary, right? You know, it could lead to, for example, your home vacuum robot being hacked, or maybe, you know, a service dog that's being controlled by a hacker that's from a remote server. And, you know, you recognize that the security and privacy having kind of afterthought in this space because there's such a high speed of innovation. But at the same time, as the amount of automation grows, there are also risks that we should think about, right? For example, if there's an attack on one of these robots, it could lead to a human being injured by the robot and other bad things that can happen. So the goal of this workshop was to gather experts from academia and industry and to try to identify some major challenges in security, safety, and privacy of robotic systems, and also think about some promising approaches. What are some directions that we could work on together to help improve the security and privacy of robotic systems? So one of the major outcomes of this workshop was a white paper that contains a summary of the discussion points as well as recommendations for future research. So if you're interested, there's a QR code there that links to the white paper that you could take a look afterwards. But let me just give you a quick highlights from the discussions that we had at the workshop. So one of the major questions that we discussed is, what is the threat model for robotic systems? And then we found that basically a lot of existing threat models in traditional computer security don't quite apply to robotic systems, right? And that we don't really have a lot of knowledge that's in collective sort of space that can be used by practitioners as well as researchers to understand and also to secure these kind of systems. So we thought that there is a need for maybe a new database of attacks and vulnerabilities similar to CVEs or CWEs that we all know. Another major topic we discussed was the attack surface of robotic systems. So what are the set of components and supply chain that we need to worry about that could be exposed to an attacker? And then here we concluded that compared to traditional computer security systems, robotic systems have a much larger, more complex attack surface. We have to worry about hardware, software, as well as some part of the supply chain and machine learning models, as well as humans that are interacting with the system. So the attack surface is much more, I think, complex and heterogeneous in nature. And therefore, we need a system level approach to understanding and to apply the knowledge about these different kinds of components to reason about and to mitigate risks that may emerge in robotic systems. Another major topic we discussed was evaluation. How do we evaluate and test the security of robotic systems? And here we found that there isn't really a lot of good metrics that can be used to test or evaluate security of robotic systems. And also, there isn't a lot of good data sets out there that can be used by practitioners and researchers. And so we thought that there is a need for a better way to test and certify robotic systems, and not just during the development, but also after the systems deploy into the wild, right? The real hard work begins when you have a system that's in the real world, interacting with other things, other physical parts, and also the systems is being updated over time with new features and patches that are uploaded to some kind of network, right? So there's a lot of that thing, security that needs to be done, not just during development, but also during the deployment. And we think that this is another major challenge that we should address in the future. Now, last but not least, we also discuss external factors such as the humans and the regulations around these systems. And what we found was that human factors are very much underdeveloped, and that there is interesting challenges between transparency. So what does this system tell the human about what the robot's doing? For example, what kind of data is collecting? Versus building trust in humans, right? Does human actually trust that robot will do the right thing, or they will not, collect those data and then send it off to somewhere else to be sold? And we also discussed that a lot of existing cybersecurity guidance don't quite apply to robotic systems, and that again we need to develop a new set of guidelines and policies that can be used by developers, and also learn from past accidents, right? Can we do better based on the failures that we have experienced in the past? So that was a quick summary of the key points that we found in the workshop. And now I'll pass off to Sarah.
All right, thank you. So long term, we have this vision at RSPI, at this Robotics Security and Privacy Institute, to build an integrated framework that can address security and privacy across all of these aspects of robotics. So if you're building a new robot, you can use it to anticipate what security and privacy issues you'll have, what needs to still be done in real time, all this stuff. If you've bought a robot, whether that's as a business or as a consumer, you'll be able to use it to understand the security and privacy limitations there are on your device, what options you have for improving them, and hopefully be able to, adapt all of these specific things for specific needs. Because as we've seen, security is difficult on a good day, robotics is difficult on a good day, and every particular situation is different. So we need something that will really work for all of these different use cases. So to that end, this is all going to be built on this shared knowledge base of common weaknesses and vulnerabilities in robotics that was mentioned. We heard from a lot of folks at the workshop that in and of itself would be really helpful as a way to start understanding what the problems are, what kinds of things you can anticipate before they happen. And the ultimate goal is to do all of this in a streamlined and automated way that really ties everything together for a specific robot or for a specific use case. But of course, that's the long-term vision. So in pursuit of this, we're going to talk about a couple of things that are on the horizon right now that we are starting to do now. So for the first one of these, we'll pass to Lehman.
All right, so CyLab is very good at making software more secure and more private. So here, the first thing we would like to tackle is to improve the security and privacy of software and firmware systems in robotics. So there we have kind of supply chain problem. In there are so many components, and each component also have third-party libraries. So the components can be untrusted. Some of them are just buggy, the development may not be malicious, but the bugs will lead to vulnerabilities. So we're trying to figure out what are the best way for us to even apply existing best practices in terms of security and privacy to secure the system. So in terms of what's going forward, we're aiming to raise the security waterline, essentially first to apply existing ideas, then we'll figure out what are the new methodology we need to specific address to issues in the robotic systems. So we are planning to write proposals to address open source software systems, things like ROS2. That's one of our target or we'll be looking at next. Back to Sarah.
For another thing that is ongoing, looking at the privacy side, we're building a compendium and taxonomy of attacks and defenses on privacy specifically in robotics. So this is unifying privacy concerns in the human-robot interaction literature, as well as technological privacy issues like network information, revealing location data, and other stuff like that. And the main goal here is to, one, understand and unite these two different areas. We see that users are identifying a lot of privacy issues that maybe aren't addressed so much by technical means. There are a lot of technological underlying issues, again, in the networks and in the way that the robot is processing something that might not necessarily be the first thing that somebody buying a robot would think of. So we're really trying to unite those two things, see what the state of affairs is, and really start contributing to defenses on both sides of that kind of question, and really have a more holistic, united view of privacy in robotics. And then last, I will pass to Unsuk once again.
So another thing we're looking at in this work or initiative is, of course, AI and then safety, right? So as you may know, more and more AI is used to, as part of the systems. For example, when you have an indoor navigation robot and you have a transformer-based model that's controlling, generating actions for the robot to perform. And we also know that AI is not perfect yet, right? It's going to sometimes hallucinate. It's going to generate outputs that are potentially bogus or dangerous. And so the question here is, how do we build robotic systems that's based on AI, but that are still also trustworthy, right? That we can actually rely on them for potentially safety critical tasks, such as navigating indoor space or carrying objects and things like that. So one of the things that we're doing as part of the initiative with Basti and support from Bosch is trying to build guardrails around these systems, right? So if, let's say you have again, a navigation robot that's trying to move or go to some destination and is using AI to generate actions, control actions, how do we ensure that the system doesn't do things like running into an obstacle or human? And can we, again, design a guardrail to ensure that the system will behave safely despite mistakes in AI? So yeah, this is another direction that we're looking at. This, I think, is very exciting, interesting.
All right. So, as you can see, there's already lots of exciting things going on. And as you can imagine, you might have your own really exciting problems and challenges that you are thinking about. And all of these things together are this starting point of Robotic Security and Privacy Initiative, or RSPI. So overall, we are going to be and are conducting both foundational and applied research towards a secure, privacy-preserving robotics ecosystem that is safe and trustworthy by design. We're leveraging all the expertise at CMU across all of these different areas, AI, cybersecurity, privacy, many more. And to meet the demands of industry and government and society, we're also doing this in collaboration with partners. So ultimately, it's an all-hands-on-deck situation, transforming this research into practical real-world solutions. We are targeting this at a lot of real-world use cases, including the ones listed here. We're trying to focus on areas that are most critical to our partners and to the broader industry, and also where we sort of see the most need for the security and privacy aspects of robotics. And like I said, CMU is really well situated to tackle these. So there are already efforts among all of these different areas across CMU. So not only CyLab, but also SEI, the Software Engineering Institute, NREC, the National Robotics Engineering Center, and many, many departments across CMU, including all the ones listed here. And you can really see how these issues need a lot of attention, both from the computer science, the ECE, the Robotics Institute and stuff, as well as more, the policy side, the, software and societal systems, HCI. All of this is once again all hands on deck situation to make robots secure and private. We have over 36 CMU folks already involved. The expertise spans robotics, AI, machine learning, autonomy, security, privacy, HCI, formal methods, IoT, lots more things, many words on this that you can just see the whole variety of different lenses through which you can look at this problem. Looking at engagement and partnership, we are looking at this multifaceted engagement model that is building on other successful CMU and CyLab models. So there are quite a lot of ways to get involved. Many of these are through CyLab proper, and I'm going to talk a little bit about this specific RSPI research initiative model. So similar to some other CyLab initiatives, we really want to make sure this is a real partnership. We're envisioning an annual cycle where partners have the opportunity to describe what they're looking for. This can be more targeted or more broad, depending on the needs, and yielding this internal request for proposals. Faculty will submit proposals, and those will be scored and awarded jointly by the co-directors and partners. And then there's engagement. So we'll start with a kickoff conference, depending on the needs of particular projects and partners and faculties. There are lots of opportunities for continuing engagement, updates, and so on. We hope this will lead to fruitful collaborations, whether that's one long project or multiple long projects or several shorter term questions. So that is RSPI in a nutshell. If you are interested in learning more about partnership, there is a QR code you can scan to learn more. You can also connect with Michael or Jason at these locations, and at least I think they're both here also. And so now I would like to move on to our panel and Q&A. So Lori briefly introduced him earlier, but I'd like to reintroduce Dr. Jorge Guajardo Merchan. He's a principal scientist and senior manager of the Security and Privacy Research Group at Bosch, and he has generously agreed to moderate the panel that we have with the RSPI co-directors, at least all the ones who could make it here today. So here we go.
All right. So thank you, Sarah, for the kind introduction. It's a privilege to be here today and to have been invited to moderate this discussion. Some sort of rules of engagement, if you will. Anyone in the audience, in the physical audience, please feel free to raise your hand and ask questions. You are highly encouraged to do so. For the people that have joined us remotely via the Zoom call, Michael has kindly accepted the job of monitoring the talk, and then he will be able to see when there are questions that are raised, and he will ask them live here in the in the room. So with that, let me just start with a very interesting first paragraph of this report that was created about a few weeks ago, because I find it very exciting, right? So it says, the era of robotics has arrived with physical AI and autonomous systems leaving the control confines of the research lab to become integral components of our homes, factories, and critical infrastructure. So that's exciting, right? That's a new era. We know that AI is here and that robotics is coming to our lives. Yet, this rapid expansion, while heralding a new wave of innovation and productivity, has also exposed a critical and underexplored challenge: the need for comprehensive, systematic approach to robotics, security, and privacy. And so that should maybe scare us a little bit, gives us a job for those that work on security, right? We need to solve some problems. So with that, I would like to ask the panel to start the discussion. What are those unique challenges that you find at the intersection of robotics, privacy, and security? And why are they so hard to solve today? So, Yusuf.
Yes, I can start. So I think there are at least two unique challenges here. So first is just the attack surface being so heterogeneous in nature, right? So you have to worry about attacks on software, for example, an attacker trying to compromise a system through some kind of remote access server. But you also have to worry about physical attacks on sensors that the robot's relying on to obtain information about its surrounding, and also the humans, right? You also have to worry about the humans that are always interacting with the system. So I think this is what makes robotics much more challenging than perhaps traditional computer security. The second thing that's unique about robotics, I think, is that there are other kinds of system requirements besides security, right? So in security, we often worry about confidentiality, integrity, availability. But in robotics, safety is also very important, right? So you have to worry about, for example, the robot not hitting a human or running into an obstacle and causing damage. And so you often have to think about if the attacker is able to compromise the system, and let's say maybe obtain some data, how does that lead to potentially a violation of some safety requirement? So I think there's an interesting interplay between security and safety that we should think about. And also sometimes security requirements interact with other operational requirements like timing or energy consumption, right? So if you want to deploy a very computationally expensive encryption mechanism, they might not also be possible because these devices are not, they're not supported by high power, right? They maybe on some battery that doesn't last a very long time. So you have to think about the trade-off between security and other requirements like energy consumption and others. So I think this is what makes robotics unique compared to traditional security.
Any other thoughts?
I mean, some of the other things are just sensing action, right? So you have a very unique sensing and timing requirements. I think those give a lot of rise to many issues. And then, of course, once you can do action, now you can reposition, you can harm, you can spy, you can do many different things once you can actually have action. And that brings out a completely new paradigm of how you can think about vulnerabilities that I think people have not traditionally looked at. And then, yeah, resource limitations for sure, right? Like, there's also some economic questions, right? If you have this most secure system, but it's too heavy or too fly or too expensive to even deploy, then it can be secure, but it's never going to get deployed, right? And the other part of it is that you used to say basically like the biggest spy is basically the phone in your pocket, right? But I think people have locked down phones pretty well, right? But now the next weakest link all the robots coming into our houses, right? Or wherever they go, where we haven't had time yet.
Sarah, do you want to add?
Yeah, I just want to mention as we started looking at this question of privacy in robotics, we ran into a lot of problems that sort of were the same vague type as the kinds of problems that we'd seen before, but so for instance, transmitting data, to a third party, or maybe using network metadata to guess something about, what the robot is currently doing. And those problems still exist in other things, like regular computers have this problem, IoT devices have this problem, but we found that they often started taking on more importance when it was robotics. So first of all, a robot typically has a lot more sensors than your average IoT device. Depending on what's going on the computer, you still have some of the same issues of, maybe not all kinds of data sent to a third party are what you would want, but, now it's, constant camera data, or now it's, the layout of my house, or, now it's the layout of a secure space that's not supposed to have cameras in it, really, so a lot of the issues really take on a new challenge. Even existing privacy issues took on a new challenge when we looked at them in the context of robotics.
Right. Any other thoughts?
Maybe just
add for the heterogeneity of the components. So if you have one robot, depending on the nature of the robot, it might have lots of different components, also different things. So there, because they are, each robot is an autonomous entity, somehow the end-to-end, the full stack security analysis and guarantee become important, also very difficult to do. We cannot just say, oh, this sensing piece is safe, but you have to say, when you put together with the firmware, with the hardware, is the robot going to behave badly? It's going to harm the privacy of the kids they're interacting with. I think that's kind of more difficult to make it more secure, more preserve the privacy.
Okay, great. So now we know that, security and privacy research in robotics might be hard. So we now move to how we do the research, right? And to do research, we need a platform. So, and robotics is very broad, right? There are a large number of systems. You can go from, say, vacuum cleaners to autonomous driving to, say, drones. So which system should we tackle? And is there a particular system that is better suited to do research and that you will try to tackle first?
So I think there are many different systems we could start with, but actually in my interest, are a lot of drone systems, right? And I think drones are maybe a good example in the sense that they represent a lot of the challenges and are very widespread, right? So you have a lot of them are used for camera-based information gathering, and vulnerabilities in them can be have big consequences depending on the scale of the drone, right? And you could think about these vulnerabilities going all the way from the tiniest drone that's a toy to a big drone that's flying people around. And so I think the same applies to the humanoid RC car driving. I think there's many different examples. I think it might be useful from an initiative perspective to think about a common denominator that's like a small, kind of affordable way that exposes the same issues over a broad range. And in that sense, I think a drone is actually kind of nice because it's very, small and relatively easy to work with. But I think other platforms could be, for example, some lower cost quadrupeds or something like this.
Any other thoughts? Any thoughts in terms of software platforms or particular frameworks that you would like to target?
So I think on the software side, ROS and ROS2 has become quite popular, and it has lots of issues. So it's a great starting point.
Okay, great. Yes, please.
What about not just the?
Yeah, thanks. So good. Okay. In terms of digital twins, so I'm thinking beyond just what runs within the hardware, but the way that it interacts in an ecosystem, the way that we imagine and understand its impact and engagement, and the way that it changes engagement within spaces, not just industrial, but maybe civic. So I'm very much interested in thoughts about validation and how those, like, for instance, are digital twins a valuable means to create modeling spaces? How do you look at when the robotics kind of come out of the lab and get further down the track? Hopefully some people can speak about that too, whether right now or in the course of the panel.
So I think the main thing we run into with sim or in robotics is so one way we try to deploy it is to say, hey, you have some domain randomization, you try and make it broad enough that it covers the space of what the system will see. So it's very successful for, let's say, control, like reinforcement learning, for like learning some policy. But it always comes at a trade-off, right? So if you try and make something very robust, it's going to be less performant because it can't optimize to exploit everything, right? So you might end up with some walking policy, let's say, that's super stable, but is very energy inefficient or something like this. So if you think about it in terms of robustness and the security part of it, if you have a simulation or a representation that then the system fits to very well, then it becomes very vulnerable when you change it, right? So if, like, I don't know, the floor in your training wasn't as slippery as it is in real life, and you never had a banana peel in your sim, then the system will become unhappy, right? So, I mean, I think that's kind of the space to think about in terms of digital twin simulation, maybe.
I guess just to add on to this, I do think there is a lot of this tied up in this longer term vision that I've been describing, where we're going to have this sort of overarching, way to identify security and privacy issues. Many of those are things that perhaps using the digital twin kind of infrastructure would actually really work well for. Many of them also, for all the reasons you said, it's maybe not going to get everything. For all the reasons you said, it's maybe not going to get everything. So I definitely think it is definitely part of what we're going to be looking at going into the future. Maybe not all of it, though.
I mean, I think you can definitely find some, I mean, you can use it as adversarial testing as well, right? For sure.
Yeah, the same with security, right? If you do vulnerability testing, if I found vulnerability, I can verify does it exist in the real system, then fix it. But you cannot really do security or privacy by construction on digital twin because you don't know what real life scenario, whether it apply or not, right? So for testing, bug finding in the security side is definitely useful, yeah.
Okay. Did you want to follow up with any?
Sure, thank you.
Yeah.
Yeah, I mean, and whether anyone wants to address it right now or going forward, but my thoughts about the digital twin space also are almost towards a digital twin for cybersecurity itself. That is to say, the larger policy ecosystem, the digital twin of a city, and the way that we consider the way we either create opportunities, limit them, engage culture, or don't, beyond just maybe the simulation aspect of digital twins, which is typical, but thinking about the larger way that we reason about our opportunities in a region, things that are beyond and the individuality of the platform, and maybe more about the space that it affects and how those changes maybe are good or bad, in different ways, how we qualify opportunities that come out of it. So I really am trying to think more kind of broadly, whether you want to say economically, socioculturally, et cetera, as the quote space of the digital twin.
Right. Okay, so Michael?
Yes, so a clarifying question. Can you please clarify the difference between security and privacy and robotics in the general area of autonomous cyber-physical systems, such as a small nuclear reactor?
Every robotics project I have worked on has to start by figuring out what the contours of the definition of a robot is for the specific instance that we're looking at.
I can try and answer.
Yeah.
I guess one thing I see is that in robotics, there's I feel like there's much more dynamic interaction with the environment. Like, so you have to, for example, the human that's always interacting with the robot, right? If you have a smart home, robot that's going around talking to your children, I think that's very different from a nuclear plant, right? Like there's a lot more interactions, and maybe because of that, there's a lot more like unpredictable scenarios that may arise. All right. So that I see that as one major difference. It's just that like robot is always deployed in an environment that's always changing, and that you may run into scenarios that you just didn't expect at design time. Whereas in nuclear plant, you have to think about all the possible cases, right? All the bad things that happen. And you can probably do that because the environment is much more constrained compared to something like, robotics system that's in the wild, in the, somewhere flying in the air, for example.
Anyone else?
As a roboticist, I have no comment.
I
Trying
think-
to define robotics is very hard. It's a dishwasher robot.
Really though, I think it'll be interesting as we go forward to see when the, maybe something that we are building as a defense for a robot is still quite applicable to a lot of these other settings also.
Also, in general, people seem to lump robotics and autonomous system together. Many of the research and also grant proposals, opportunity, they always say robotics / autonomous system. So I don't know if we need to split that specifically.
Okay. So I think this is a good segue for the next question. So we've seen the rise of AI and LLMs most recently. So agents, right? LLMs talking to each other. And even more recently, we have seen how they can be tricked into doing stuff that you didn't expect them to do. So what are the security and privacy impact of adopting agentic systems in robotics?
I'll talk a little bit about this. I mean, so I said earlier, security and privacy is hard on a good day. AI is also hard on a good day. Robots are also hard on a good day. So putting all of those things together is going to be really difficult. I think you can already see some of the issues coming along. So like Lehman was talking about earlier, the idea of, when we have this potential ecosystem of robots using potentially autonomously going to go collect new tools to incorporate into themselves as they are agentically, deciding how to move forward. I think we are going to see a lot of security problems that are reminiscent of problems of just running any untrusted code or going and grabbing any untrusted code and trying to run it. But again, now because it's in a robot, we're going to have these additional issues of pretty severe physical consequences when something goes wrong. And, whether that means somebody gets hurt or whether just the robot is going away, I think we're also going to see quite a bit of difficulty around being able, like the interface between safety, security, and functionality. So you want to have the robot be able to do the thing and be able to do it in a safe way, but also do it in a way that doesn't trip security alarms. And I think that's going to be quite challenging. I don't know if anyone else has opinions.
I just have a quick comment. I think for robotics, one of the things that's interesting is that over the last 30 years, right, people have figured out how to build safe robots, right? And you could think about the, of course, there's so the agentic AI part comes kind of from the other side and now starts to have action and closing the loop and so on. But on the other hand, kind of robotics has come the other way, essentially bottom up on that side. And I think a lot of the ideas and techniques that were developed there can be leveraged in this space. So I think just because it's a physical system, there are some things that are just make sense and don't make sense. So in sometimes that makes things a little easier rather than some random tool that does something that has no context, right?
Okay, cool. Another question?
Yes. What important or surprising things have we learned about robots, privacy and security from the rollout of autonomous vehicles such as taxis over the past year or two?
Anyone wants to take this?
I'll start on the privacy side only, which I think I'm been thinking about more. On the privacy side only, I'll just share an anecdote of some friends who live in San Francisco who now play the game of like hiding their faces from the Waymos, right? And like hiding their faces from, all these sort of autonomous vehicles that are now out on the streets. We've also seen some initial things, right? It's sort of, again, the privacy issues are reminiscent of things like rideshare apps, but now you also have this physical component to it, and you potentially even have these, vehicle to vehicle communication component or vehicle to, X components to it, where what data do you actually need to transfer off in order to make whatever traffic decision you're trying to make and stuff like this is certainly for privacy, it is very difficult to do that in a way that doesn't end up devolving into just share everything. And security too.
I guess at least to some people, what was surprising about these self-driving vehicles, like back in 2016 or 2017, like all these companies were claiming that their cars will be on the road by 2020, something like that, right? But that hasn't really happened to the extent that they wanted to. And I think they're realizing in that going from like 95% to like whatever is required, minimum threshold for safety is really hard, right? There's going to be scenarios or situations that you didn't expect that you couldn't test for. So I feel like that was a surprise. And my speculation is that there could be another set of surprises coming because a lot of these companies are now thinking about incorporating end-to-end machine learning, right? So like using something like LLMs or transformer-based models to like do the entire stack of driving. And that I think could introduce another set of surprises, right? These things are not perfect yet. So how do we test that they're going to be reliable in practice? So I think that'll be my prediction. That we're going to sort of see, things are becoming more innovative. At the same time, it takes time to get them to be reliable, for us to, use. And so that would be my guess. That's going to happen in the next 5 years.
I think I'll say one more thing. I think we're also only seeing the beginning of what I'll call like adversarial attacks on cars. There's been a handful of things in the news and in research looking at, trying to get the cars it doesn't have to be a car, but trying to get the vehicles self-driving to do something that the human driver would never have done. And this is so far, I think, more successful than is ideal. And I think we've only seeing the beginning of that.
Yeah, I mean, maybe just as a general comment, right? You have purely from a company perspective, you have basically your IP riding in that vehicle, right? so I think in terms of physical attacks, it's also very vulnerable. You have and additionally, usually these vehicles have a comms link, right? That's required for their total safety case. So for example, if a Waymo or something really gets stuck, they call home and then somebody kind of teleops it, right? And so there's many ways to make that vulnerable, right? Like, you could have just some jammer, then the comms link is out. I'm sure if you plug into the CAN bus, you can, drive that vehicle around however you want to. So I think, it's actually very vulnerable. I mean, if you get in one and you plug in the front, you could probably just drive it around, is my guess. So,
any comments from the audience?
Anybody wants to have some fun, paper?
Yeah.
About the adversarial effects you mentioned, I know you said it's like a long-term goal to be able to automatically test everything. So how might you automatically test these sorts of AI integrations and stuff?
One message for me coming away from the workshop was that testing is never going to be the whole thing. The amount of, even without the adversarial aspect, the amount of just hours you would need to do is just too much to make testing the only thing that you can do. So there are also, right, you sort of want to motivate your design in a way that you think is going to be secure in the first place. Given that we know about the adversarial stuff, I think there are defenses at least that work against the stuff we know how to do. And I think that's always, there's a little bit of cat and mouse there, as there often is in security. Yeah, it's really going to be an interesting thing. And
because in software systems or IT system, you have red team or penetration testing. In robotics, I don't think even that exists, right? They do safety testing, not necessarily security pen testing as much.
So one of the things, I guess I forgot to add a slide, but Luyo Bao and I have a project on drone adversarial robustness related things. So for example, and we're going to try and do this kind of red team, blue team approach where we basically say, hey, let's attack this algorithm, we'll improve it and go back and forth. And then one of the ideas for evaluation that we've been discussing is this idea of trying to set up kind of a test bed that maybe is even remotely accessible, where we'll have some drones in the down at the rig in the new drone cage that you can then run, and we can do these adversarial kind of experiments on. And so I think that's kind of the high level vision of where we want to go. And that way, we at least have some test bed to try and do some of these attacks.
Another question.
So a popular question is, you've heard how hard security and privacy is. Are there any aspects of robot security and privacy that you're optimistic about? as they're already well served by the application of security technologies and methods from other markets domains. So what are the promising security approaches for robotics?
I mean, I do think it helps a lot that we're not starting from zero here. Like, you know, even as we were describing the, I think Lehman was describing that a lot of security considerations that we sort of already know how to do, we just need to, you know, apply them in the case of robotics, are likely to get us reasonably, you know, it's a lot better than not doing it. I'll put it that way.
If you look at every single piece, right, firmware security, there people know how to do better testing, securing firmware, software, same thing, open source software, supply chain security. Those are all active areas of research, AI, safety. But if you put everything together, top to bottom down the stack is getting a lot more tricky. But yeah, those are the places. Piecemeal solution is we can probably apply right away. And then how do we compose them so we can have end-to-end security and privacy? That's the next step.
I guess I'm a little bit more optimistic about the policy side here because there is sort of, you know, safety considerations like safety risk here, and they might push the public to perhaps, you know, encourage the government or the companies to come up with some kind of regulation or some kind of guidance, right? That says, you know, you should not deploy a robot that could kill somebody because of security attack. So that's the part that I'm also optimistic about, that there might be maybe some encouragement to the developers of these systems to really get security right, because otherwise people could get hurt.
And have some hardware skin in the game also.
Yeah, that too.
Yeah. Okay, so one of the things that came out from the workshop was that threats and vulnerabilities were not very well understood for robotics, right? Even though there are lots of lists of threats and vulnerabilities in other domains, right? So where should we start to build such a knowledge base for robotics, and what would be needed to maintain it?
I think one starting point is kind of what Sarah's doing with privacy. The first thing is do proper categorization. I guess this goes along with what's a robot? Like, there are so many different kinds of robots. Each one of them will have different security models. The first step is to actually categorize different type of robots, then categorize the type of security vulnerabilities or security requirements we want on each type of robots. And then we can go down to the more detailed knowledge of what are the attacks we care about, what are the good properties we want to have, so on and so forth. Maintenance is extremely tricky, even in the software world, right? So CVE is a reasonably okay example, but still there's different agencies accept CVE, they review them differently. When we report CVE, from the side of finding problems, we realize that the people who are reviewing CVE, they really don't want to put the CVE unless it's necessary, because put the CVE on open source, anything is very bad for the developers. So they're very conservative about when they actually want to assign CVE. So it's not that easy, right? So we can learn a lot from the software world, but even in the software world, it's actually not that perfect. But yeah, ideally, there should be different set of agencies depending on, you know, nature of the problem, which component you're reporting, and then somebody would have to be behind this and reviewing the bugs and putting it on a common database. Yeah, it's tricky.
So I think right now there's a lot of companies, startups out there, you know, developing robots, right? And they would love to have something where they can say, hey, if I do this, I followed good practices, I've done the right thing, you know, I'm covered, right? Like nobody likes security except for, you know, what? Well, except for the researchers in it, right? Like, you know, it's extra cost, annoying, right? But you know, it's very high stakes, right? So if you have all your robots out there, and then you know all the Waymos, somebody chose, I don't know, Waymo with a 0 instead of an O at the end as a password, right? Then that's a huge problem, right? And so I think having some standard of good practices and then getting people behind it so that, you know, it does not risk their company, right? I mean, this can totally kill like especially a small startup, it can totally kill, right? And so I think people are really clamoring for something. And so I think that is and there are some unique aspects where it basically goes into the safe, if you develop a robot, right, you make a safety case, and as part of it, you would have some of these security and privacy things in there. And I mean, some good practices, some extensions of some existing practice would be, I think, a really good first step. Yeah.
That's a question.
Yeah, next question from the audience.
Thank you. What are some of the collaborations that you're looking for in private industry that would help the Institute?
Why is everyone looking at me? Yeah. I mean, I think, we're looking at kind of things all over the place, like all over the stack, I guess. There are a lot of different components in robotics. So we spoke with people at the workshop that were chip designers, people that built robots, people that bought other people's robots and wanted them to be, secure for whatever it was they were doing. I think what our plan is to have this cycle of engagement where if, an industry partner is working with us, they'll basically be able to, kind of describe what their particular situation is. They'll see what kinds of research we are currently doing and be able to kind of make a match there. I don't know if Michael actually wants to talk more to this.
I mean, I think other things would be like use cases, for example, like saying, hey, we have this problem. We think this is difficult. We always like hard problems, right? I think that's a good thing. Also, yeah, I think it can even go the other way, right? If you're more on the security side, right? Like saying, hey, how do we kind of integrate some of the findings? I think it can go both ways.
And like we were saying, there's a lot of kinds of robots. So, in some sense, we're also looking to see what the needs are.
If I may add something, since I have the privilege to work with CyLab for a long time now, it helps always to bring these really unique problems that you have and work together with the researchers to try to solve, brainstorm, create projects together, and then have the potential to deploy those solutions that have been developed, perhaps, jointly in an actual plant, in an actual system or something, so that you can actually verify the practical impact of that. So yeah, that's my experience. That's it for time. Okay, I think then we're done. I think there might be some last words from Sarah.
It's basically the same as these words, but I guess we just... Oh, okay. We wanted to thank everyone for coming for sure. We encourage you to check out the workshop report to see what kinds of stuff we were able to discuss both with industry and the academics to see what kinds of stuff we're currently thinking about. It's a big, scary world out there for privacy and security in robotics, but we're also very excited to improve this, and hope you're as excited as we are to build these secure and privacy preserving trustworthy robots. So yeah, please check out the report and feel free to reach out to Michael and Jason to discuss further. Thanks.